to first get comfortable using logarithms, let's go ahead and rearrange a logarithm so it looks more like an exponential problem that we're used to seeing. So to do that, I've got a logarithmic equation right here. We'd read that as log base 2 of 8 is equal to 3. Now notice just a couple details real quick. If I were writing this on a line, notice log 8 and 3 are all on the same line, the same level, and that 2 is a subscript. It's written down below. So 8's not an exponent, 2 is the only thing that's not written on that line. So we'd read this as log base 2. When I start to rearrange this, then that 2, I just said it was base 2, represents the base. If I'm writing this in exponential form, you can kind of see my finished product over here. I'm going to show you how I got that answer. Now the answer to a logarithm is always an exponent. So when I have the equal sign here, that 3 represents an exponent that I found. So I'm going to write 2 raised to the 3rd power, and then needs to be equal to that last number left over. So there's what this would look like written as an exponent, just simply rearranging something that's a logarithm into something that we're more familiar with, and that's an exponent, or exponential form. And I can always check that I rearrange correctly, because 2 to the 3rd should equal 8, and yes, of course it does. So let me show you one more, and then I'll have you guys pause the video and try the next few on your own. So my next equation says log base 4 of 1 is equal to 0. If I want to write that using exponential form, 4 is my base. The answer to a logarithm is an exponent, so 0 is going to be my exponent. And then I'll put that equal to 1. And of course I could check that, and 4 to the 0 power, anything to the 0 power besides 0 is equal to 1. So that's true. Okay, so go ahead and pause the video and try these next couple examples. If you want to just watch it play through, you can see my answers pop up. But I'd recommend you pause it and try those on your own. So hopefully you came up with the same thing when you rearrange your logarithms. One quick note I want to make about that second one. I use parentheses around the 1/4. You don't really need to do that, but I did. If I'm checking it, one thing I may not know is I may not know that 1/4 to the negative 3rd is 64. So I could check it on my calculator, or I want to show you a quick little trick we can use that may be helpful in some of the next examples we'll look at in the next video. So to take a negative exponent and make it positive, normally we move something up or down on the elevator, we called it. The other way to change a negative exponent into a positive is just to take the reciprocal of what's in parentheses. So if I take the reciprocal of 1/4, I get 4. That would also have the effect of changing my sign to a positive 3. So that's just kind of a side note. It may be helpful in the next video we do about actually evaluating logarithms.